Hello everyone, welcome back to Science Academy. So all of you know that CPET 2022 examination form already bahar sarchi. So आपण preparation को एबटू strong करंतु. Okay, so any kind of preparation जेतोला आपण करछन्ती तो maximum two factors आपण ता ऊपर ध्यान देबे. For example, जेमति कि any kind of entrance exam रे जेमति कि syllabus is very important and then previous year question paper important. Okay, so we all of you आम समस्ते सिलेबस को तो 100% कंप्लीट करछे बट गोटे इंपोर्टेंट फैक्टर को आमे ध्यान दोने जोटा कि प्रीवियस ईयर क्वेश्चंस. ओके, तो इधर आमे प्रीवियस ईयर क्वेश्चन को कंप्लीटली सॉल्व करने अदरवाइज प्रीवियस क्वेश्चन को ओनली आंसर की पछरे आमे सर्च करछे. ओके, तार डिटेल एक्सप्लेनेशन और पाठ भीतर को आमे एंट्री करने. दैट्स व्हाई आई ब्रिंग CPET फिजिक्स 2021 रो प्रीवियस ईयर क्वेश्चंस विथ डिटेल एक्सप्लेनेशन जोटी कि मु एवरी क्वेश्चन विथ सेमानकर बेसिक कांसेप्ट को एठी डिस्कस करबी. आई मीन पाठ भीतर को मु एठी एंट्री करबी. ओके, सो मे बी एवरी वीडियो रे मु 1 to 2 क्वेश्चंस विथ देयर सॉल्यूशंस आपन मानको प्रोवाइड करिया चेष्टा करबी. सो वीडियो रे जदी किछि डाउट रहे किछि कंफ्यूजन रहे क्वेश्चन रे ताले आपन माने मो सहित कांटेक्ट करि परंती. ओके, सो लेट्स स्टार्ट आवर फर्स्ट क्वेश्चन CPET फिजिक्स 2021 रो. The question given that a heated body emits radiation which has maximum intensity near the frequency f0. The emissivity of the material is 0.5. Okay, and if the absolute temperature of the body double, then what happens? The given four options. Likewise, the maximum intensity of radiation will be near the frequency 2f0, or the maximum intensity will be near the frequency f0 by 2, or the total energy will be increased by factor of 12, or the total energy will be increased by factor 8. Okay, so पिला माने एठी देखो क्वेश्चन को डिटेल पूछो कौन देछि हम क्वेश्चन देछि गोटे हीटेड बॉडी दैट एमिट्स रेडिएशन ऑफ ए पर्टिकुलर फ्रिक्वेंसी. ओके, तो आमे जेतबेले बॉडी रो इंटेंसिटी को ग्राफ आमे जेतबेले चेक करछे, सो इंटेंसिटी विजिबल होछि को रीजन रे ना गोटे फ्रिक्वेंसी रीजन दैट इज द वैल्यू इज f0. ओके, तो बॉडी रो एमिसिविटी दे देछि दैट इज 0.5. ओके, सो इफ द टेम्परेचर बिकम्स डबल, सो टेम्परेचर जदि डबल हुए ताले कोन होय देखंतु फर्स्ट ऑप्शन दीटा एंड सेकंड ऑप्शन दीटा को मार्क करंतु. फर्स्ट ऑप्शन रिलेटेड फ्रिक्वेंसी. ओके, तो मैक्सिमम इंटेंसिटी को फ्रिक्वेंसी रेंज से देखा जो इधर 2f0 और f0/2 आम डिस्कस करिया. आउ दीटा सेकंड दीटा ऑप्शन रे सी देछि द मैक्सिमम इंटेंसिटी रे जो एनर्जी प्रोड्यूस हो. ओके, और द एनर्जी एमिशन हो. सो एनर्जी रो इंक्रीमेंट केते हो बाय फैक्टर ऑफ 12 और बाय फैक्टर ऑफ 8. तो फर्स्ट मु ऑप्शन 2 और ऑप्शन सी एंड डी को क्लियर करिया चेष्टा करछि. तो देखंतु आमे जानछे बोल्ट्जमैन्स लॉ. ओके, what it says, the rate of energy emission per unit area is given by capital E, that is the rate of energy per unit area. This equals to E sigma T fourth. Okay, so already we have know that E is called the emissivity of a body. Okay, sigma is the Boltzmann constant and T is the temperature of the body that emits heat radiations. Okay, that means we know the energy E is proportional to fourth power of temperature. Clear? For example, here it given that the temperature becomes double. Okay, for example, when you do E2 divided by E1, okay, ratio pointed korea, then this should be equals to T2 divided by T1 whole to the power 4. Clear? Acha, so we know that the T2 this is equals to twice of T1, temperature becomes double. That's why we write here as T2 T1 divided by T1 to the power 4, and the answer becomes 16. That means the new energy will be 16 times the old energy. Okay, but here the factors are given by 12 and 8, so C and D will not be possible, so C and D is wrong here. Okay, then we'll go for option number 1 or option number 2. Now we'll come to Wien's displacement law. Okay, we'll come to Wien's displacement law. So question asla why एठी मु Wien's displacement law को मु एठी यूटिलाइज करली, बिकॉज एठी देखंतु टेम्परेचर एंड फ्रीक्वेंसी भितरे आई हैव टू रिलेट. ओके, सो टेम्परेचर एंड फ्रीक्वेंसी भितर एनी काइंड ऑफ रिलेशन को मुझे ट्राई करी प्लेस करबा पे. अच्छा, व्हाट इज वाइन्स डिस्प्लेसमेंट लॉ सेज दैट लैम्बडा टी दिस इक्वल्स टू सम कांस्टेंट और बी. ओके, this is called Wien's displacement law. That means lambda is always inversely proportional to the temperature. Clear? Now we know that the energy E this equals to hc upon lambda, where c upon lambda this is the frequency f. Clear? That means c upon lambda is the frequency. That means the lambda, okay, the wavelength is inversely proportional to the frequency, or the frequency is inversely proportional to lambda. Okay, from this question, okay, this equation number 1 आपको हम एमती लिखि पड़ियो ना, lambda 2 divided by lambda 1 this equals to T1 divided by T2. because lambda is inversely proportional to temperature. So lambda 2 by lambda 1, that means T1 by T2 होगा. Okay, as एठी देखंतु lambda is inversely proportional to frequency, that means एठी मो इक्वेशन कोन पिला माने फाइंड आउट करि पारि ना lambda 2 divided by lambda 1, this should be equals to f1 divided by f2. Okay, so now दीटा इक्वेशन को मार्क करो. Okay, from these two equations lambda 2 by lambda 1 equals to T1 by T2 and lambda 2 by lambda 1 is frequency f1 by f2. That means whenever, so right side the equation automatically equal होगा, that means f1 by f2 this equals to T1 by T2. Clear? Okay, एटी मु रेसिप्रोकल फाइंड आउट करछि, f2 by f1 this equals to T2 by T1. Clear? Now पिला माने ऑब्जर्व करो, given that T2 becomes twice of T1 and the original frequency is given by f0, so f2 divided by f0 this equals to 2, because 2T1 by T1, T1 cancel, this gives 2. Therefore the new frequency f2 should be equals to twice of f0. Clear? That means the intensity that is visible in the region or near the frequency range 2 f0. So according to this, the option number 1 will be the correct answer, that is I maximum will be near the frequency 2 f0. Clear? So this is the question number 1 solution. So students, now come to the second question. Okay, the second question is given that an ideal refrigerator has a freezer at a temperature of minus 12 degrees Celsius. The coefficient of performance of the engine is given by 5. So the temperature of the air, that is to the which heat is rejected, is dash. Okay, so it heat rejected temperature एठी हम क्वेश्चन पचार. तो ता पूर्व हम देखो एठी आइडियल रेफ्रिजरेटर देछि, तो रेफ्रिजरेटर ऊपर डिटेल्स हम टिके कांसेप्ट बुझे. देखो, this is the diagram for refrigerator and this is the diagram for heat engine. So we know that the Carnot cycle, okay, the Carnot heat engine is a reversible heat engine. That means it is simultaneously the Carnot cycle can operate as a heat engine as well as can operate as a refrigerator. That's why this is called the reversible cycle. First understand the concept of heat engine. In this heat engine, this is called the hot body, okay, or the body or the engine, okay, the engine of the body, where this is called the hot body or this is called the source at temperature T1. So the amount of heat, that is Q1, is the amount of heat. This is absorbed by the heat engine. The heat engine performs some work, that is W, and then the remaining of the heat energy it rejects to the sink that's maintained at the temperature T2. Okay, so here we know that the total energy absorbed, that is heat energy absorbed, Q1 equals to the work done plus the amount rejected, that is Q2. That means the work done value is equals to Q1 minus Q2, that is the difference of the heat energy. Now come to the refrigerator, okay, and the refrigerator is exactly opposite that of the heat engine. Here what happens, the temperature, that is, or the heat energy Q2 from the cold body, that is from the sink at temperature T2, is given to the heat engine. The heat engine, there is some work done on the system from the external, okay, externally. So whenever externally work done on the heat engine, okay, because the W is given towards the arrow mark, the arrow mark is given towards the heat engine, that's why work done on the system. Clear? Here I have mentioned it. So work done, W is on the system or on the engine, and then Q1 is the amount of heat energy that is rejected to the source, which is maintained at temperature T1. So here in this cases, the coefficient of performance, that is beta, is given by Q2 by W. But in this case, we call it the efficiency, and the formula of efficiency we know, that is Q1 minus Q2 by Q1, where this can be written as Q1 minus Q2, we know this is the work done, clear, divided by the amount of heat absorbed. But here this is exactly opposite. This is equals to the amount of heat absorbed, that is here Q2, divided by the work done. Okay, here given T2, okay, here mention T2, this equals to minus 12 degrees Celsius. So convert this into SI unit, that is Kelvin. So for Kelvin purpose, we just simply subtract 12 minus 12 from the 273 Kelvin, and if you subtract, the value will be 1, 6, and this is 2, that is 261 Kelvin. Now put this in above equation. So now we will find a relation between beta and eta. The relation is given by eta equals to 1 by 1 plus beta. Okay, a relation को पिला माने भल्ला रे मन रखो. I can prove this for you also. Okay, we know that beta this equals to Q2 divided by Q1 minus Q2. Now add 1 both sides. So 1 by beta equals to 1 plus q2 divided by q1 minus q2. Therefore 1 plus beta, this equals to q1 multiply 1, so minus q2 plus q2 divided by q1 minus q2. That implies 1 plus beta, this equals to here minus q2 plus q2 cancels and q1 divided by q1 minus q2. As you know that the value of eta is q1 minus q2 by q1, and here it is the reciprocal of this, so it can be written as 1 by eta, or eta equals to is given by 1 by 1 plus beta. So we'll put this value, okay, in the above equation. How? Okay, check that the value of eta. What is the value of eta here? 1 by the value of beta is given by 5, so 1 by 6, this is eta. Okay, now we know that the value of eta, okay, so eta equals to 1 minus t2 divided by t1. Okay, this equals to, put the value of eta, that is 1 by 6, 1 minus, what is the value of t2? 261 by t1. So what we have to do, just solve for the value t1. Okay, so when you solve for this t1, you will get the answer. Okay, and t1 we can write this as okay, simply just modify the value of t1 by take 1 by 6 on the right side and 261 by t1 on the left side and solve this. So after solving, we will find the value of T1, that is 313.2 Kelvin, and convert this into degrees Celsius, that will give the answer, that is 40.2 degrees Celsius. Okay, so the option, from the option you check that 40.2 degrees Celsius is the correct answer for these questions. Thank you.